Hey everybody, this is our next example from section 2.4, looking at one-sided limits. And here we are going to be taking the limit as x approaches 2 of the function absolute value of x squared minus 4 over x minus 2. Okay, so notice that this is not a one-sided limit given to us in the problem. We're taking the limit as x approaches 2, and that's a general limit, so that means to come in from both sides. Okay, but if we think about it, let's think about our tricks from the previous section for evaluating limits. The first trick was direct substitution. We can't do that because if we try to plug in x equals 2, the function's going to be undefined. So that happens a lot. Factoring and canceling almost would work on this, but not quite because of those dang absolute value bars in the numerator. If we've got an absolute value around that, we can't just directly factor and cancel. Okay, but we'll kind of keep that idea in mind because inside the absolute value bars, x squared minus 4 would factor nicely. It's just we've got to do something about those absolute values first. Okay, so that's an idea. Our other idea was multiplying by a conjugate. There isn't really a conjugate to use in this problem, so that's out. And then our fourth one was to use the sandwich theorem or squeeze theorem, which you might consider that for this one, but it would be pretty tough to find two functions that would sandwich this particular thing here. So yeah, we don't really have too much we can do with those four techniques right now. So that's why we go to this fifth technique from this section, the idea of one-sided limits. And so we'll see what happens with that. Now, remember we considered that idea of factoring and canceling because the numerator's almost really nice, except it's got absolute values on it. So we're going to take this off to the side for just a second because you may or may not know there are alternate ways of writing absolute value functions. So we could write this absolute value function, absolute value of x squared minus 4, or any absolute value function really, can be written as a piecewise function. Okay, so we can split this up into multiple parts. And, you know, the piecewise functions will have like some expression if x is in a certain range of values, another expression if x is in a different range of values. That's what we're going to be trying to set up here. So we need to find out what that range of values is going to be based upon. And the idea is to basically scrape out the inside of the absolute value, the x squared minus 4 in this case, and set it equal to 0. This is going to serve as a nice kind of dividing line or dividing mark because absolute value of 0 is just 0. It doesn't change anything really when we take the absolute value there. So this will be a nice kind of basis for us to use. Okay, so if we solve that, x squared equals 4, square root both sides. Remember that there's going to be a plus or minus on this, so x equals plus or minus 2. Okay. Now, let's think about what the expression x squared minus 4 is doing along the number line. Okay, we're going to split it up with x equals -2 and x equals +2. And then we'll kind of test in these different chunks of the number line what's going on with this expression. Okay, and what we're really interested in is going to be, is it positive or negative in those different areas? So in the middle here, kind of that central chunk of the number line, you might pick a test value like x equals 0 and plug it in to our x squared minus 4 expression, and we would end up getting -4. No matter what value you pick in this interval in the middle here, the result is going to turn out to be negative. Okay, we'll see why that matters in just a minute here. Now let's pick something over to the right of 2, like x equals 3, for instance. Plug that in. Oops. Okay, I already went a little fast there. 3 squared minus 4, 9 minus 4, would be 5. And regardless of what value you pick over there, the result is going to be positive. And then you do the same type of thing over here to the left of -2. You might pick something like x equals -3. That would be in that region. Doesn't really matter which value you pick over there. Ultimate result will be the same. We end up getting positive values over here as well. Okay, so we can see what x minus 4 is doing in different parts of the number line. Now, we want to think about the absolute value of x squared minus 4. That's what we're really interested in. But we know what the interior is doing, so we've just got to take the absolute value of that. Okay. Now, the thing about absolute values, if you'll remember, is that an absolute value always returns a positive result because it's measuring a distance away from 0. So distance, we assume that is going to be positive, and absolute values turn out positive. So we want to make sure that in each segment of the number line, our result for the absolute value turns out to be positive. So interesting. Now you might notice that here and here, those portions of the number line, x squared minus 4 is positive already. In order to take the absolute value, we don't really need to change anything about those numbers. They're already positive, so that's like good to go. So the absolute value of x squared minus 4 is just going to be x squared minus 4 if x is in either of those two regions. That would be if x is less than -2 or x is greater than +2. Okay. Now we need to address this region in the middle here. X squared minus 4 is negative in that region. And so we don't want to just put x squared minus 4 right here because then that would be negative and we don't want our absolute value to be negative. So how we can take that negative number and make a positive result come out of the absolute value is by multiplying by -1. So we're going to take -1 times x squared minus 4, or do the opposite of whatever value we're getting, okay, to make it positive if x is between -2 and +2. Okay. Now you might look at that and say, well, what if x actually equals positive or -2? And there's not really a standard convention for that. Because remember, when x actually equals plus or minus 2, the value of x squared minus 4 is 0. So it doesn't really matter which category you lump that into, 0 or -0. It's still just the same thing. So you can put the little or equals to wherever you like, really. I'm going to stick it on here. Okay, so x less than or equal to -2 and x greater than or equal to +2. Okay, so that is how we can rewrite an absolute value function as a piecewise function instead. And notice now the different pieces inside there don't have absolute values anymore. This is going to be really convenient for us on this problem. Okay, so let me kind of mark this as some scratch work off to the side. We're making a new function there, new representation of that function. And now we can use that and approach our one-sided limits. Okay, one-sided limits. No other trick was really working here. All right, so first, let's take the right side limit or right hand limit, x approaching 2 from the right of absolute value x squared minus 4 over x minus 2. Okay, and so what we're going to do is we're going to use our piecewise function here to rewrite this numerator just without absolute values. Okay, so let's see which part of the piecewise function we are going to be in, if we're going to be in this portion or if we're going to be in this portion. Okay, and the key to deciding that is looking at the one-sided limit that we're taking. X is approaching 2 from the right. So we want to pick something that is to the right of 2. Okay, let's go back to this little number line again, convenient. Here's x equals 2, and we want to pick something to the right of that. So that would be in that rightmost part of the number line, which that would be x greater than 2. That would fit into this category right here. Okay, so we are going to use this for x approaching 2 from the right. Out of room there, 2 from the right. That tells us we can replace our absolute value function with this portion of the piecewise function. We can just say x squared minus 4 instead of absolute value of x squared minus 4, because we're in the right range of x values, basically. Okay, so we get to rewrite like this. I'll make a little note for us. Use the piecewise function here. Okay. And now this problem becomes very nice. We can use our previous trick of factoring and canceling. It's okay now because we've gotten rid of that absolute value. And so we'll factor that nice difference of squares there and cancel out the x minus 2 term that was preventing us from doing direct substitution. So we are going to be able to do direct substitution now at this stage. So we're just taking a limit as x approaches 2 from the right of x plus 2. There's no problem with plugging in now. We can plug in. You're going to use x equals 2 to plug in. Even though it's coming from the right, remember that you plug in the value that's being approached when you're doing direct substitution. So we just get to say 2 plus 2. So that's going to equal 4. All right, so that is our right hand limit. And now we're going to do basically the same thing for our left hand limit. We're going to take the limit as x approaches 2 from the left. Remember, that's not negative 2, that's 2 from the left. Look where the minus sign is. And originally we do have our absolute value function in there. But again, we're going to be able to use our piecewise function to replace that. So approaching 2 from the left, here's 2, here's numbers to the left of 2. Now remember, you don't need to go super far away, like even though this is technically to the left of 2, we actually want to be approaching x equals 2. So don't get too far away there. So we're looking like in here at these values, approaching 2 from the left. So that's going to be in this middle region of the num line right here. We're going to use this for x approaching 2 from the left. And so we're going to be able to plug in this part of the piecewise function. Okay, so we're going to have limits. X approaches 2 from the left. And then it's negative x squared minus over x is 2. So that again is using the piecewise function. Okay. And then the process looks very similar from here on out. We're going to factor again. Factor the difference of squares and cancel out that x minus 2 factor. And so we're going to have a limit as x approaches 2 from the left of negative, parentheses, x plus 2. Okay, so now we get to plug in because it's not a domain problem anymore. This is actually going to be defined now. So we get to plug in, again, x equals 2, the value that's being approached, even though it's coming from the left this time. And so we have negative, parentheses, 2 plus 2, and we get negative 4 for that left-hand limit. Okay. So remember, our original problem is not asking for specifically left-hand and right-hand limits. It's looking for the overall limits. And remember, for a general limit to exist, we need these two one-sided limits to come together. These guys do not. One's going towards positive 4, one's going towards negative 4. The y values don't match up. So our conclusion here is that the limit as x approaches 2 overall of absolute value x squared minus 4, I will squeeze it in here, over x squared minus 2, does not exist. That is our final answer because the one-sided limits are not equal. That's our justification. All right. And there we have it.